All right, let me take you through this question, right? Um, in the diagram, ABC is a tangent to a circle at B. So this is the tangent that we are having over there. Then see that it is tangent just at B. So BDEF is a cyclic quadrilateral. So we do have now a cyclic quadrilateral over there. So once you have it, we have a tangent now. We also have a cyclic quadrilateral. So these are the two main critical things to note, because there are theorems around these two shapes. Yeah, you can call it a shape. The tangent is a shape, right? Which is just in a form of a straight line. Now, we have this other additional information that BD is equal to BF. So looking at BD, where is it located? You can see that these two lines that are equal to each other are actually chords, right? So now you need to remember the theorem around the chords, right? Especially when they are in one circle, that equal chords subtend equal angles at the circumference of the circle. So you can see that now this angle will have a complete relationship with this other angle, because we know that they are facing equal chords, right? So equal chords subtends equal angles at the circumference of the circle. So if E1 is X, then so do E2. Yeah. Now we also have to be mindful about finishing the statement that is given to us, so that we don't miss out any information that is provided to us, because mostly they just give the trick of putting the information on the statement and not in the diagram. So should you miss that one, you may kind of like take more than enough time to figure out the information that you haven't read it there. Now we have this information. So now let's get into the question, right? In the question, we have B1 being equal to E2. We have to prove that they are actually equal to each other. So coming to the diagram, and we can see that in the position of EB1, B1 is actually in the middle of, or it is subtended by the tangent and this chord BD. So this angle, since it is between the tangent and the chord, you can see the theorem is talking just with you. Now we are having B1, which is supposed to be equal to E1 due to the reason of tan chord theorem. So this is what we just generally know. By doing that, we are trying to get close to A2, because we can see that B1 and A2, there isn't any close relationship between these two between these two angles, but we can find some connections around it so that we can get them. Now, and you have to get there sooner than ever. So we have B1, which is equal to E1. Reason, we have tan chord theorem, right? Tan chord theorem. So should you have that, we know that from the onset we did discuss about these angles that are being equal to each other, that E2 is equal to E1, raising equal chords subtends equal angles, right? So we have that information. So that's what makes B1, since B1 is equal to E1, we did prove that, and E1 is equal to E2, also proved that over here. So B1 is just now equal to this other angle. So we are done for that one. So it is very wise to know that once you're given the tangent, make sure that you find a way to use it, or the quadrilateral, because the question or the statements, the information that is provided, it helps you to make sense about what is needed, what is not needed, what can you find, what can you use, and stuff like that. So it is not there for decoration or to make the question looks nice or confusing. So it is there for a specific reason, right? Let's come to number two. Number two, we are to prove that triangle BDA is actually similar to triangle EFB. So we have these triangles. Let's just indicate them so that we know which angles are we looking at and which triangles that we are comparing. So let's just have them in different colors so that we just avoid some little bit of confusions. Now we are to find that, or we are to prove that these two triangles are having three corresponding angles that are equal. So yeah, I'm saying three corresponding triangles, not because only that condition can give us the information of the similarity. It's because we don't have information about sides, so we have to opt for the second one, since we know that for similar triangles the corresponding sides have to be in proportion. That means they have to give us the same ratio. And also the second one is to make sure that all three triangles correspondingly equal to both triangles. So that is what makes it to be understood that these two triangles are similar to each other. So we just need to find all those three corresponding angles. So it is with our calculation that we already found that B1 is equal to E2. So we can just say proved by having that. Let me not write with that because I really don't have I don't have the space for that. But let's just discuss about this question. So B1 is already equal to E2 in the other triangle. So we have that being proven right just now. Then we also have these other two angles that we need to find the relationship with, because we need to find all of them equal and correspondingly equal. But we can see that we are given the cyclic quadrilateral over there. So should you be given the cyclic quadrilateral and we haven't used it yet, so it might be time now to find a way to utilize it. Now, looking at D1, you can see that D1 is actually the exterior angle of this quadrilateral BFED. So the theorem around this exterior angle is that this D1 has to be equal to F, because this is the opposite interior angle of the same quadrilateral. So we now have two angles found equal in these two triangles. So we just know that these third angles, they don't have a choice. They have to be equal to each other, because both of these two triangles, they have to give us the sum of 180 when you are adding their interior angles. So by that, then therefore these triangles are similar to each other. We are done. Coming to the next question, which says 9.3. Prove that BD squared is equal to DA times EF. Should you have that BD squared, you probably have two sides that are equal to each other. That involves BT as well. So BD is found equal to BF, of course. So that means BD times EF is just BD times BD. That makes BF. So you just need to make nice corollary using this information over there. BD divided by EF is equal to DA divided by FB is equal to AB divided by BE and all that stuff, so that you can just cross multiply and find that useful. So it is just that for this question, it wasn't difficult. It just needed you to be able to quickly find all these missing and hidden angles in this question. So you just need to find a way to actually get familiar with all the information that is provided, because it is there for a reason. When you have a tangent, tan chord theorem is possible. Then cyclic quadrilateral, opposite interior angles, then they are supplementary. Then you also have the exterior angle. Should you have one, then it is very important to see how you can then use it. So it is basically that for this question. See you in the next one.